You think you understand comets? Ice balls from the edge of nowhere that light up when they get close to our sun, simple physics, predictable chemistry. But on July 1st, 2025, a telescope in Chile spotted something that breaks every rule. 3 Asteroid Atlas. The third interstellar visitor we have ever seen, racing toward us at 137,000 miles per hour from a place older than our solar system. And in mid-September 2025, it started doing something that made scientists around the world stop and stare. This is not about space rocks. This is about an object that produces nickel vapor without iron, that turns from red to green in a matter of days. That generates a coma 348,000 kilometers wide, filled with carbon dioxide instead of water. Chemistry that does not exist anywhere in our solar system. Behavior so strange that Harvard's AV Loeb called it a possible Turing test by superior alien intelligence. If you value documented space science like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. This script is researched and factual, using sources from the Very Large Telescope observations published in the Astrophysical Journal, letters on August 25th, 2025, and polarimetric studies from 4S2 VLT. Alfosk not. And Ferrero 2 RCC published September 9th, 2025. These are deep observational papers that most people never see. Now back to the information. The story starts May 7th, 2025. 3. I-Atlas is 6.4 astronomical units from the Sun, beyond Jupiter's orbit. NASA's transiting exoplanet survey satellite captures something impossible. The object is already active, already glowing, already producing a coma 26,400 kilometers wide. Comets do not do this. Water ice does not sublimate at those distances. The radiation is too weak, the temperature is too low. Michigan State University's Adina Feinstein combed through the data months later and found the truth hiding in plain sight. This thing was releasing carbon dioxide and carbon monoxide long before any natural comet should wake up. July 1st. The Atlas telescope in Rio Hurtado, Chile, officially discovers 3I Atlas at 4.5 astronomical units. Hyperbolic trajectory. Interstellar origin confirmed within 24 hours. David Jewett and Jane Liu, using the Nordic Optical Telescope on July 2nd, confirmed clear cometary activity. But here is where it gets weird. Miguel R. Alarcon's team at the Instituto de Astrofísica de Canarias finds the same activity pattern using the 2-meter twin telescope. Multiple independent confirmations of the same anomaly. A reddish coma that should not exist. July 21st. Hubble Space Telescope captures the highest resolution image we have. What it shows violates everything we know about comet behavior. The glow extends toward the sun, not away from it. An anti-tail, light scattered in the wrong direction. The surface brightness follows a power law slope of -4, steeper than any solar system comet ever observed. Eric Keto and Avi Loeb analyze the data and reach a disturbing conclusion. The steep brightness profile suggests the nucleus itself might be generating light, not reflecting sunlight, creating it. August 6th. James Webb. Space telescope locks onto 3. I-Atlas at 3.3 astronomical units. NIR spec integral field unit provides spatially resolved spectroscopy. The results rewrite comet chemistry: 87% carbon dioxide, 9% carbon monoxide, only 4% water. Martin Cordner from Catholic University calls it the highest carbon dioxide to water ratio ever seen in any comet. This is not how comets form. This is not how ice condenses in protoplanetary disks. This is something else. August 8th through 12th, SphereX Space Observatory detects the impossible, a carbon dioxide gas cloud spanning at least 348,000 kilometers in radius, visible only in near infrared. The size of this emission region defies every model of cometary outgassing. Standard physics cannot explain how carbon dioxide maintains coherence across such distances. August 14th, very large. Telescope in Chile detects cyanide gas for the first time. By August 21st, the emission rate hits 17.6 grams per second. But here's what makes astronomers lose sleep. The production rate scales with distance to the power of -9.38. Small changes in solar distance trigger massive increases in cyanide output. This is not thermal sublimation. This is threshold chemistry. Process activation. August 20th. The discovery that changed everything. Rohan Rahatgankar's team, using VLT's X-shooter spectrometer, detects 22 distinct nickel emission lines, blazing atomic nickel fluorescence under solar radiation. Production rate of 4.6 grams per second. But iron lines are completely absent. In 40 years of comet observation, nickel and iron always appear together. They form in supernovae together, they exist in meteorites together, they outgas from comet nuclei together, always. Except in 3, I Atlas. Nickel without iron is the signature of industrial nickel refining, the nickel carbonyl process, advanced metallurgy. On Earth, we separate nickel from iron to make specialized alloys, shape memory materials, aerospace components. But this separation requires technology, energy, intent. August 27th, Gemini South Telescope reveals the anti-solar tail in multiple spectral bands, a teardrop shape 56,400 kilometers long pointing southeast. Images in U, GE, R, and I bands all show the same anomalous structure. Light where light should not be. Dust trails that ignore solar wind physics. September 4th, South Gemini Telescope captures the most detailed image to date. The tail is longer, the coma is brighter. Activity is accelerating as 3. I Atlas approaches perihelion, but the chemistry keeps getting stranger. September 7th, Michael Yeager and Gerald Riemann photograph 3 I Atlas turning green. Deep imaging shows a distinct color change from red to blue-green. The transition correlates with the explosive rise in cyanide production detected by VLT. Green comets exist. Dicarbon molecules create the fluorescent glow, but this color change happened in days, not months. Rapid chemical evolution that suggests internal processes we do not understand. The numbers tell the real story. 3. I Atlas was emitting log Q of 21.26 nickel atoms per second when first detected at 3.9 astronomical units in July. By August 21st at 2.85 AU, production had exploded to log Q of 22.67 atoms per second. 25-fold increase in 1 month. The scaling follows R to the negative 8.43 power. Solar radiation scales as R squared. Surface heating scales as R to the negative 0.5. The observed scaling is 16 times steeper than thermal physics allows. Cyanide follows an even more extreme pattern. First detected August 14th at 3.07 AU. Production rate hits log Q of 23.61 molecules per second by August 21st. Scaling of R to the negative 9.38. Temperature-driven sublimation cannot explain these numbers. Something else is driving the chemistry. September 9th through 10th. Gerald Riemann captures the blue-green gas coma measuring 2.5 arc minutes across. A short tail becomes visible. The object is brightening to apparent magnitude 14.7, still too faint for visual observation, but brightening faster than standard models predict. The polarimetric data breaks the final rule. Z, Gray's team using force 2 on VLT, Alphos on NOT. And Fourier-2 on RCC measures polarization over phase angles from 7.7 to 22.4 degrees. 3 I Atlas shows extreme negative polarization, reaching minus 2.7% at 7 degrees phase angle, inversion angle of 17 degrees. This combination is unprecedented among asteroids and comets. Even the previous interstellar comet TU I Borisov showed normal positive polarization. 3. I Atlas represents a distinct type of object, a new class of interstellar body with optical properties that do not exist in our solar system. The trajectory itself defies probability. 3. I Atlas approaches the ecliptic plane at an angle that suggests targeting, not random ejection from a distant star system, but a path calculated to intersect our inner solar system. The hyperbolic excess velocity of 58 kilometers per second is fast enough to escape any stellar system, but not so fast as to suggest chaotic ejection. Controlled departure. October 3rd, 2025. 3. I Atlas passes within 29 million kilometers of Mars. High-rise camera aboard Mars Reconnaissance Orbiter will capture images at 30-kilometer resolution. These observations will determine whether the brightness comes from a giant nucleus or a dense coma. The size mystery will finally be resolved. Current estimates range from 440 meters to 5.6 kilometers diameter. But if Avi Loeb's calculations are correct, the nucleus could be 20 kilometers across. A rock that size from interstellar space should be impossible. The reservoir of rocky material between stars cannot supply objects this large more than once per 10,000 years. October 29th, perihelion at 1.36 AU. Closest approach to the Sun, maximum heating, peak outgassing. If 3 I Atlas is hiding something, the Sun will force it to confess. High-stress environments elicit revelations. Solar wind pressure will strip away any camouflage. Thermal shock will test structural integrity. Whatever this object really is, perihelion will reveal its nature. The implications cascade through astronomy. If 3 I Atlas is a natural comet, then we need new physics to explain its chemistry. Carbon dioxide-dominated outgassing suggests formation in environments colder than anything in our solar system. Nickel without iron implies selective depletion mechanisms that do not exist in known astrophysical processes. The extreme polarization signature points to dust grain properties never before observed. If it represents technology, then we face a different problem. Interstellar travel requires energy expenditure that dwarfs human civilization. Trajectory modification demands propulsion systems beyond our current understanding. The chemical signatures could represent industrial processes scaled to astronomical levels. Manufacturing in the vacuum of space using raw materials extracted from cometary ice. The SETI Institute's Allen Telescope Array collected 21 terabytes of radio data during the first week of observations. Wael Farah's team searched for both natural emissions and artificial signals. No technosignatures detected. But radio silence does not prove natural origin. Advanced civilizations might communicate through channels we cannot detect: quantum entanglement, gravitational waves, neutrino beams. 3 I Atlas originates from the Milky Way's thick disk. A population of stars 7 billion years old, twice the age of our solar system, material formed during cosmic noon when the universe was younger and more active. Star formation rates were higher. Heavy element production was accelerating. Conditions that might produce chemistry we have never seen. The object will remain observable through November 2025. Coordinated observations from Hubble, Webb, VLT, and ground-based telescopes worldwide will map its chemical evolution as it exits the inner solar system. Spectroscopic analysis will search for additional gases: methanol, formaldehyde, hydrogen cyanide, ammonia. Each detection will constrain formation models and eliminate possibilities. March 14th through 16th, 2026. 3. I Atlas passes within 53.6 million kilometers of Jupiter. NASA's Juno spacecraft could be redirected for a close encounter if mission extensions allow. The maneuver requires a trajectory change in mid-September 2025. Gravity assist near Jupiter. Velocity boost to match. 3. I Atlas's path. Juno's near-infrared spectrometer could analyze surface composition. Magnetometer could detect magnetic fields. Microwave radiometer could measure thermal emissions. Direct spacecraft investigation of an interstellar object. The mystery deepens with every observation. 3. I Atlas displays properties that should not coexist: natural comet behavior combined with impossible chemistry, familiar physics producing unfamiliar results. The object follows Newton's laws while violating our understanding of matter in space. The detection of atomic nickel without iron remains the smoking gun. 4 decades of comet spectroscopy show consistent patterns. Nickel and iron always appear together in predictable ratios, reflecting cosmic abundance. Solar system comets, interstellar comet. 2. I Borisov. All previous observations follow the same chemical rules. 3. I Atlas breaks them. Industrial nickel production on Earth uses specific processes to separate nickel from iron. The nickel carbonyl channel, metal carbonyls formed under controlled conditions. High pressure, precise temperature, chemical engineering. But these processes require infrastructure, energy sources, technological civilization. How do you build a nickel refinery in interstellar space? The alternative explanations stretch known physics to breaking points: exotic nuclear chemistry in stellar cores that preferentially produces nickel, selective depletion mechanisms that remove iron while preserving nickel, radiation processing during millions of years of interstellar flight that alters surface composition through unknown pathways. Each possibility requires new science. The carbon dioxide dominance points to formation conditions absent in our solar system. Protoplanetary disk regions, so cold that water remains frozen while carbon dioxide sublimates. But such regions exist too far from parent stars to accumulate substantial solid material. How do you build a comet where physics says comets cannot form? The extreme negative polarization signature indicates dust grains with properties never before observed. Light scattering behavior that implies particle sizes, shapes, or compositions unknown in solar system objects. 3. I Atlas reflects photons and patterns that violate established optical models. New mineralogy, exotic crystalline structures, microscopic architectures designed rather than evolved. September 11th, 2025 marked a crucial milestone. 3. I Atlas reached apparent magnitude 14.7, still 140 times fainter than the visible comet Lemon, but bright enough for sophisticated amateur telescopes to track. Citizen scientists worldwide joined the observation campaign. Distributed monitoring networks spanning 6 continents. Democracy of discovery as ordinary people contribute to extraordinary science. The brightness evolution follows patterns that suggest internal activity rather than passive solar heating. Light curves that climb steeper than thermal models predict. Outgassing rates that scale with distance in ways that thermal sublimation cannot explain. Energy sources inside the object that activate under specific conditions. Batteries, chemical processes, nuclear reactions, or something else. The search for truth accelerates as 3I Atlas brightens. Every photon carries information, every spectrum reveals chemistry, every polarimetric measurement constrains physical models. The object cannot hide much longer. Perihelion approaches, maximum energy input, peak performance. Whatever technology or exotic physics drives its behavior will be exposed under the sun's relentless scrutiny. The scientific community divides into camps. Natural origin. Advocates seek increasingly complex astrophysical explanations, unusual formation environments, exotic ice chemistry, unprecedented radiation processing. Each new observation forces more elaborate theoretical constructions. Occam's razor cuts against natural explanations. Artificial origin proponents point to the accumulating anomalies, industrial chemistry signatures, trajectory targeting, behavior that suggests design rather than chance. But extraordinary claims require extraordinary evidence. Radio silence argues against active technology. No obvious propulsion signatures, no response to our observations. If 3I Atlas represents alien engineering, it operates by principles we do not recognize. The polarimetric observations published September 9th provide the strongest evidence yet for truly alien properties. Negative polarization reaching minus 2.7%. Inversion behavior at 17 degrees phase angle. Dust scattering characteristics that exist nowhere else in the solar system. Not unusual, not rare, impossible under known physics. Light polarization depends on particle size distribution, shape characteristics, and refractive index. Solar system dust follows predictable patterns based on formation through collisional cascades, grinding of larger bodies into smaller fragments, size distributions that reflect impact physics. 3. I Atlas. Dust violates these distributions. Particles with properties that cannot form through natural breakup processes. The antitail remains the most visually striking anomaly. Comets develop tails pointing away from the sun due to radiation pressure and solar wind. Basic physics taught in introductory astronomy courses. 3. I Atlas shows the opposite. Light extending toward the sun, matter flowing upstream against the solar wind. Impossible unless internal forces exceed external pressure. Directed energy, controlled emission, technology. October 3rd will provide the crucial test. Mars opposition places 3I Atlas in optimal viewing geometry. High-rise resolution of 30 kilometers per pixel. Not enough to see surface details, but sufficient to distinguish between nucleus-dominated and coma-dominated brightness. If the central condensation appears point-like, the nucleus is small and dense coma explains the observed flux. If extended structure becomes visible, we are looking at the largest interstellar object ever detected. The size question determines everything. A small nucleus, surrounded by dense gas and dust, implies exotic outgassing physics. Sublimation mechanisms unknown in solar system comets. Chemistry that releases matter at rates far exceeding thermal equilibrium predictions. Energy sources that power continuous activity across astronomical distances. A large nucleus suggests a different problem. Rocky bodies 20 kilometers across should not exist in interstellar space. The population statistics do not support such objects. Formation mechanisms cannot assemble that much material in unbound orbits. We should detect thousands of smaller objects before encountering one this large. The absence of other interstellar visitors argues against a natural explanation. The nickel emission continues its exponential rise. Current production rate of 4.6 grams per second represents megatons of processed metal over the object's active lifetime. Industrial quantities. Mass processing on a scale that dwarfs terrestrial metallurgy. If this represents technology, we are observing engineering projects beyond our current capabilities, manufacturing in the vacuum of space using techniques that separate elements with atomic precision. The cyanide production adds another layer of mystery. Hydrogen cyanide formation requires high temperatures and specific chemical precursors, stellar atmosphere chemistry, industrial processes that combine carbon, nitrogen, and hydrogen under controlled conditions. But 3. I Atlas produces cyanide in the cold vacuum of space billions of kilometers from any star. Chemical reactions that should not occur are happening at industrial scales. The color change from red to green represents rapid chemical evolution. Surface composition modifications that occur over days rather than geological timescales. Either the object contains volatile reservoirs that activate in sequence, or internal processes are manufacturing new compounds in real time. Chemistry as dynamic process rather than static composition. The radio silence remains puzzling if 3I Atlas represents active technology. 21 terabytes of data from Allen telescope arrays show no artificial signals, no beacons, no communication attempts, no response to our observations. Either the object operates without radio emissions, or it chooses not to announce its presence, stealth technology, or indifference to detection. The timing of the discovery raises questions. 3. I-Atlas was detectable months before official discovery. TESS observed it in May. Archive searches found it in pre-discovery images extending back to March. Why was it not detected earlier? Are we looking at a gradual activation process? A system that remained dormant until reaching specific trigger conditions? Solar distance? Gravitational field strength? Something in our solar system that awakens sleeping technology. The hyperbolic excess velocity of 58 kilometers per second represents controlled departure from its origin system rather than chaotic ejection. Escape velocities calculated to achieve specific trajectory targeting. Course corrections that place the object on an ecliptic intersecting path. Navigation that suggests intent rather than accident. But intent implies intelligence, planning, technology capable of interstellar travel. The chemical signatures accumulate beyond coincidence. Carbon dioxide dominance, nickel without iron, cyanide production, anti-solar tail structure, extreme negative polarization. Each anomaly might have natural explanations. Together they point toward artificial origin, technology masquerading as a comet, intelligence testing our ability to recognize the obvious. Harvard astronomer Avi Loeb frames 3I Atlas as humanity's Turing test. Can we distinguish natural from artificial when both appear in the same data? Advanced civilizations would understand that intelligent species recognize familiar patterns. Space rocks are common. Ice and dust outgassing is predictable. Hiding artificial objects among natural phenomena requires sophisticated camouflage, but perfect camouflage might be impossible. Anomalies leak through despite best efforts. The approach to perihelion will stress test whatever systems drive 3I Atlas behavior. Solar heating will peak. Radiation pressure will maximize. Thermal shock will challenge structural integrity. If the object conceals technology, perihelion passage will reveal its limits. Maximum performance under extreme conditions. The moment of truth. Ground-based telescopes worldwide prepare for the crucial observations. Very large. Telescope, Gemini Observatory. Subaru Telescope, Keck Observatory. Coordinated monitoring campaign spanning multiple wavelengths. Spectroscopy to track chemical evolution. Photometry to measure brightness variations. Polarimetry to characterize dust properties. Every available instrument focused on a single target. Space-based assets join the observation network. Hubble for high-resolution imaging. Webb for infrared spectroscopy, Spherex for wide-field monitoring, TESS for continuous photometry, Parker Solar Probe for solar wind measurements, multiple platforms providing complementary data streams, redundant observations to eliminate instrumental artifacts. The discovery of 3I Atlas marks a watershed moment in astronomy. Interstellar objects represent the only way to study material from other star systems without leaving our solar system. Chemical archaeology of distant worlds. Formation conditions in alien environments. Physics that operates under conditions we cannot reproduce in terrestrial laboratories. But 3I Atlas transcends normal scientific categories. Its properties challenge basic assumptions about natural processes. Chemistry that requires industrial intervention. Physics that suggests technological manipulation. Behavior patterns that imply intelligence rather than random mechanical processes. The object forces us to consider possibilities we prefer to avoid. The scientific method requires following evidence regardless of uncomfortable implications. Anomalous data demands explanation even when explanations challenge worldviews. 3. I-Atlas presents evidence that cannot be dismissed or ignored. The observations are real. The chemistry is documented. The physics is measured. Whatever this object represents, we must confront the reality of its existence. The final revelation awaits in the soil beneath Cerro Pachon, where the Gemini South Telescope captured the most detailed images of 3I Atlas. Chemical residues from the object's passage may have settled in detectable quantities, isotopic ratios that reveal formation conditions, molecular structures that preserve chemical history, ground truth for the most important discovery in astronomy since the first exoplanet detection. 3. I-Atlas is not just passing through our solar system. It is rewriting our understanding of what exists in the universe. The question is no longer whether we are alone. The question is whether we are ready for the answer.